there's no fun. It's just you do your last lab activity on Tuesday, and then on Thursday you just come in for Thursday.
Okay.
Yeah, there's nothing else. Yeah,
Okay. No worries.
so math is for the regular semester.
Okay.
Yeah, but there's a in the summer schedule that I handed out, which is also posted on campus, and there's a line on the end of the grading rubric, and it says there's no practical, so you don't need to do those sections. Now, if you just find your folder and leave your homework in there, and also whatever is in the folder, that's yours to keep. Scantron, homework, and quizzes, all the graded material, that's yours to keep. So you can take them out, and after you put your homework in there, you simply leave the folder on the table, and that'd be good. And just a reminder, tomorrow is going to be our third exam, and the third exam will cover chapter 6, 7, and 8. Now we finished chapter 8 last Wednesday. Okay, so then the homework that you did today covers all the way through chapter 8. So I think that's for the summer. I think that's probably about the amount of time that I can actually give you to study for the third exam there. And again, it's going to be the same format: multiple choice, 25 questions, 1 hour. And if you click on exam number 3 on Canvas, there is a review and practice question set. And again, I think I put some 20, 30 questions in there. So that's something that you should expect to see similar type of questions on the third exam. Okay? And so we are really winding down. This is the last week of the instruction. Next Monday is the final exam. So we have today, with Wednesday, and then we have Thursday. Three more lectures. And we have to finish chapter 9 today, and then we have chapter 11, 10, 11, 12, and 14. And 15, I'm sorry. And chapter 15 is only, we're not covering the entire chapter. We're only introducing the basics of acid base, how we measure the acidity and basicity and that kind of thing, some basic definitions there. So instead of saying 4 chapters, there's probably 3.5 chapters, or 3.25 chapters there. And those of you who are taking Chem 102, you will have detailed discussions about chapter 15 in Chem 102, talking about the acid-base chemistry. Okay, so we will continue our discussion, and today, as Monday, and as I warned you at the beginning of the semester there, I do have the option of taking the lecture time all the way to 12:30. Most likely I won't do that, and I don't think I can last class that long. So in this case, we'll try to finish chapter 10 if we can, but if not, then we'll just leave a little bit here. So you should expect to be here to at least 10:30-ish, 10:45-ish, and I have to get back to my office by 11, so that's a guarantee you will be out of here by 11, because that's my office hours on Mondays and Wednesdays. Okay, so in chapter 9 last week, when we were talking about the chapter 9 there, in chapter 9 we were talking about Lewis structure, and we introduced some very basics about the Lewis structure, and in the end we gave you this particular list. And while prior to that slide was the guidelines on how to draw Lewis structure. And the good thing is, tomorrow when you work in the lab, there's a practice, and we're actually going to give you some models of different molecules there and asking you questions there. Okay, so this is something that you need to, I don't want you to memorize these things line by line, word by word, and really, if you practice, if you do Lewis structure enough, then you would just remember these things there. So that's the key thing here is that using the guideline, I want you to be able to draw Lewis structures for these different types of molecules there. And these are all molecules that actually follows the octet group. Each atom will have to have 8 electrons surrounding it when you finish drawing the Lewis structure. That 8 electron is either shared with another one, or it's all, well, it has to be shared. Some of the electrons has to be shared. So with the exception of hydrogen, hydrogen will only need 2 electrons. Okay, and we've done some examples on the board, and here are some more examples of how to draw the Lewis structure, Lewis structure for different molecules. There, we did carbon dioxide on the board on Thursday, so we give you a carbon-oxygen connection. Now, how to determine the terminal atom, how to share the electrons there, and then how to determine the total number of valence electrons available. Now, when you don't have enough to satisfy each of the atom with 8 electrons there, and then they have to share their double bound or triple bound. So this is a situation where we have double bound and we have triple bound there. For nitrogen molecule, nitrogen group 5A, there are only 2 nitrogen atoms there, only 10 electrons between them. If each one needs 8, well, we need a total of 16, but we don't have 16. So 3 of the 3 pairs of electrons, 6 electrons have to be shared between the 2 nitrogen atoms there. So you have a lone pair of electrons on each nitrogen atom with 6 electrons shared between the 2. And that way, each nitrogen will have 8 electrons. So these are the sample Lewis structures there. Here's another one, and ethylene, when you have carbon 2, hydrogen 4. And if you count the total numbers there, now carbon and carbon, they have to share more than just 1 pair of electrons. So in this case, we have a double bound there. And then the acetylene here, we have a triple bound, carbon 2, hydrogen 2. This is an organic molecule. And so if you count the total number of electrons there, there's simply not enough for each carbon to have 8 unless they start to share more than 1 pair. So in this case, we have a triple bound there. Okay, and so drawing the Lewis structure, being able to draw a Lewis structure is one of the basic things that we talk about in Chem 101. It's also, as a prereq for organic chemistry, you need to know how to draw a Lewis structure. Because when you deal with organic molecules such as this, and the Lewis structure indicates the distribution of the electrons within the molecule, organic molecule, and that will help you to understand the behavior of different types of organic structures there. So knowing the Lewis structure is very important. Okay, so drawing Lewis structure is there, the more practice in the textbook there. So on page 399 in chapter 9 there. There's an example, and there are 2 examples there. And also for some Lewis structures, for some structures there is more than one possible way to draw a Lewis structure. One of the situations that we showed you in class on Thursday is that when you have carbon 2, hydrogen 6, oxygen 1, you end up with 2 different structures there. We call them isomers, constitutional isomers, or structural isomers. Carbon and oxygen and carbon, they are connected in different ways. Now, there are situations, and one of the examples there, I believe, gives you the Lewis structure of sulfate ion, SO4, 2 minus. And when you draw sulfate ions, there are still, there are more than one possible ways to draw the structure there. And up to 1990s, I think I still remember seeing an article published in the Journal of American Chemical Society, or even, or it could be the other Journal of Chemical Education. People are still debating which one is a more reasonable structure. And